What is a thermostatic expansion valve, TXV? A thermostatic expansion valve, TXVD, is a precision control device used in refrigeration and air conditioning systems. Its main function is to regulate the flow of liquid refrigerant into the evaporator according to the cooling load. The TXV ensures maximum cooling efficiency, proper evaporator operation, and compressor protection. The TXV is installed just before the evaporator coil. It converts high-pressure liquid refrigerant into a low-pressure, low-temperature mixture, allowing the refrigerant to absorb heat effectively. Primary functions of a TXV. 1. Superheat control. The most important job of a TXV is to maintain correct superheat at the evaporator outlet. This ensures that all refrigerant leaving the evaporator is vapor. No liquid refrigerant enters the compressor. Compressor damage due to liquid slugging is prevented. 2. Pressure reduction. A TXV works as a throttling device. It reduces the pressure of liquid refrigerant coming from the condenser so that it can evaporate at a low temperature inside the evaporator. 3. Automatic capacity. Adjustment. The TXV automatically adjusts refrigerant flow. More flow when cooling load is high. Less flow when cooling load is low. This makes TXV systems more efficient than fixed metering devices like capillary tubes. Main components of a TXV. 1. Sensing bulb. Installed on the suction line at the evaporator outlet. Senses the temperature of refrigerant vapor. Contains a charge that converts temperature into pressure. Sends pressure to the diaphragm through a capillary tube. 2. Diaphragm. Responds to pressure from the sensing bulb. Moves up or down to open or close the valve. Controls refrigerant flow precisely. 3. Needle valve. Seat and spring. The needle and seat regulate the orifice opening. The spring provides a closing force. Balances bulb pressure and evaporator pressure. 4. Equalizer line. The equalizer measures evaporator pressure and ensures accurate superheat control. Internal equalizer, used in small systems with low pressure drop. External equalizer, required in large systems or evaporators with distributors, where pressure drop is significant. Working principle of a thermostatic expansion. Valve. Refrigerant leaves the condenser as a high-pressure liquid. It enters the TXV, where pressure is reduced. Low-pressure refrigerant enters the evaporator and absorbs heat. The sensing bulb detects suction line temperature. Bulb pressure opens or closes the valve to maintain correct superheat. Only vapor refrigerant reaches the compressor. This continuous feedback system keeps the evaporator operating at peak. Efficiency. Types of TXV systems. 1. Internally equalized TXV, suitable for short evaporator coils, used in small refrigeration systems. 2. Externally equalized TXV, used in large evaporators. Necessary when pressure drop across the coil is high. Common in commercial HVAC systems, TXV in HVAC and automotive applications. Used in residential and commercial air conditioners. Used in heat pumps, often 2 TXVs for heating and cooling. Used in automotive AC systems with refrigerants like R134A and R1234YF. Works with both fixed and variable displacement compressors. Common TXV problems and symptoms. TXV stuck open. High suction pressure. Low superheat. Risk of liquid floodback. Compressor damage. TXV stuck closed. Low suction pressure. High superheat. Poor cooling performance. Evaporator starvation. Loss of bulb charge. Valve fails to open properly. Reduced or no cooling. Maintenance and troubleshooting. TXV servicing should be done only by trained HVAC technicians. During routine maintenance, check bulb mounting. Inspect equalizer line. Check for refrigerant leaks. Measure superheat and system pressures. Proper maintenance allows a TXV to last as long as the HVAC system itself. TXV versus Electronic Expansion Valve, EEV. An electronic expansion valve, EEV, is a more advanced metering device. It uses electronic sensors and controllers to regulate refrigerant flow more precisely. TXV, mechanical control, EEV, electronic control, used in modern high-efficiency systems. Importance of TXV in refrigeration. Cycle. The TXV plays a critical role in the refrigeration cycle by controlling refrigerant flow, maintaining correct evaporation, protecting the compressor, improving energy efficiency, ensuring stable system operation. Conclusion: the thermostatic expansion valve, TXV, is a small but extremely important component in HVAC and refrigeration systems. By precisely controlling refrigerant flow and superheat, it ensures efficient cooling, compressor safety, and long system life. Without a properly functioning TXV, system performance and reliability are seriously affected.